Welcome everyone to this webinar series for Central Europe and the Baltics. And I can see we're not that many today, but these are very sad times. And I think that this part of Europe is can feel the breath of everything that's going on right now, even more than other parts of Europe. So I really appreciate that you joining, at least. As you could hear, this meeting is being recorded. The recording and the presentation will be online afterwards. And let me also, oh, sorry. No, sorry. So everything will be online afterwards, at just a few hours after this webinar. Our speaker today is David Huberman, and usually David is quite fine taking questions throughout his presentation. Is that correct? So the way you can ask questions is either by, if you can see, you can raise your hand, and then I will unmute you, and then you can ask your question yourself, or you can go to the Q&A pod and type your question in there, and I will read it out for you. That's the other option. So also, before we're kicking off, I just would like to thank everyone who is helping me promote this event. This is the Estonian Internet Foundation, Nick LV, Domreg, Budapest University of Technology and Economics, HTE, NASC, and the Nick, SK Nick. Thank you so much for helping us to spread the word about this. And with that, David, I'd like to hand over to you.
Hi, thanks, Gabby, and good afternoon, everybody. I'm going to hit my share screen button. We'll start our slides. There we go. We're going to talk today about Icann'S technical mission. And as an introduction, first thing I want to talk about is port numbers. Internet protocol uses IP addresses to figure out where to send data, right? Where's the machine that you're trying to send data to, and where's your machine that someone's trying to send data from? But once it resolves that and figures out where the machine is, it's then the transport protocols that have to figure out where on the machine is there a service listening and expecting your datagrams, right? We used to call those sockets, right? Like a lamp plugging into a wall outlet. If you plug it into the correct socket, electricity is then exchanged and the lamp turns on. Well, we call them port numbers now. In DNS, services listen for DNS on port 53. If you're going to open up an SSH session or an SSH tunnel between machines, typically you use port 22. Port 22 is certainly reserved for SSH. When you open up a web page, we used to do it a lot over port 80. Today, we more often use HTTPS, which uses port 443, right? Where do these numbers come from? You and I know that DNS is 53 and SSH is 22, but how do we know that? Where do those come from? How are those assigned? Where are those? How do people know that? How do we speak this common language for interoperability? Well, like so many things on the internet, it turns out there's RFCs for that at the Internet Engineering Task Force, the IETF. And it turns out with port numbers or sockets, there's 65,536 available ports. And it's really those first 1,024 that are the most important. And when you need a new system port for a new type of service, let's say you and I develop a brand new technology that's going to change the whole internet and it needs a port, we go through a process at the IETF, which is typically to publish an RFC or a series of RFCs. And when these are approved and when these are published, new port numbers can be assigned for this new service that's going to change the world. Who assigns that port number? Icann'S. Icann'S assigns the port number as part of a service we have called the IANA, the Internet Assigned Numbers Authority. It's IANA that assigns and tracks the port numbers. It's at this URL, which you can click on when you look at these slides. It's a database of all 65,000 ports. I took a screenshot of one of the pages, and you can see at the bottom port 53, which is marked here for domain. You can see it's actually assigned to Paul Makapetris. Paul Makapetris is the author of RFC 882, which was the first formal definition of the DNS back in 1983. There's some other port names on here. I don't really recognize many of them except for TACAX, used on router logins. But there's a whole series of ports for all the different technologies that have been invented over the last 40 years or 40 plus years. And so that's how you get a port number. Officially, this registry that's at IANA is called the Service Name and Transport Protocol Port Number Registry, okay? It's actually one of about 3,000 protocol parameter registries that ICANN has at IANA. There are lots and lots of them, from the really well-known to the really obscure. Some of the well-known ones that are very important to the function of the internet include NTP, and NTP successor, network time security, which encrypts the exchange of time information over the wire to combat against certain types of attacks. IPv4 addresses, IPv6 addresses, autonomous system number assignments, even DNSSEC. When you sign DNS data with DNSSEC signatures, you use a signing algorithm, and the protocol actually needs you to publish which algorithm you're doing, which is assigned a number, and the numbers that correspond to each signing algorithm are a protocol parameter registry. So good afternoon, everybody. My name is David Huberman. I am the manager of technical engagement here at ICANN. Finishing up my 22nd year in the world of network engineering, and most of my time has been spent on IP addressing and DNS. I've helped build some backbones, early 2000s, a DSL provider in the United States. Worked for a time at Global Crossing, which in the early 2000s had the world's largest map of routes, fiber routes across the world. And I've spent time building clouds at Microsoft and Oracle. And for the last 4 years, I've been at ICANN. I'm coming to you today from suburban Washington, D.C. in the United States. And I live here with my wife and my daughter, who are just in the other room getting ready to go to school and go to work. So I want to talk about ICANN's role today in technical internet governance and what our technical mission is. And I'm only going to talk about what I think are the important parts. We're not going to talk about any of the boring bits. ICANN is a member-driven organization. Everything that happens from the bottom up. Internet users from around the world, stakeholders who have an interest in everything that happens in internet infrastructure, come together, make policies, and really they run ICANN. And importantly, they are who sets ICANN's remit. ICANN's technical mission has been what we call tightly constrained. It's really been limited by our community so that we properly focus on essentially 5 different things. In no order, we coordinate the allocation and assignment of names. So these are top-level domains in the DNS root zone. And we're going to go through all 5 of these in details. That's what this presentation is going to be. We coordinate development of policies concerning the registration of second-level domains. Example.com is the second-level domain. We facilitate the coordination of the DNS root name server system, how it operates and how it evolves. We don't run it. We don't run the DNS root name server system. We are the facility. We are the organization where people come together to talk about, discuss, and coordinate its operation. One of the most well-known things we do, of course, is allocate and assign IP addresses and autonomous system numbers. And as well, the 5th one is what we just talked about, which are these protocol parameter registries, okay? Just as importantly as what we do is what we don't do. And these are very, very common misconceptions. My mother still thinks I control the internet because I work at ICANN. ICANN really doesn't control the internet in any way, shape, or form, because the internet isn't built that way. It's a network of many, many different networks. There's an old and very important saying in network engineering: your network, your rules. If you run an ISP, you decide what traffic you're going to accept, what traffic you're not going to accept, what rules your user has to play by, and what rules your BGP neighbors, your peers, and your transit providers what rules they have to play with, what you're willing to do, because it's your network. You run it, and nobody gets to tell you what to do other than, perhaps the law in your jurisdiction, the regulator in your jurisdiction. You work together locally to decide what's allowed and what's not allowed. But another ISP in the same country or another ISP elsewhere in the world, they don't get to tell you what to do. Your network, your rules. And so ICANN can't tell an ISP what to do. ICANN doesn't tell other root server operators what to do. We don't control the internet. Similarly, we don't control the DNS. We coordinate a lot of the DNS. We help a lot of the DNS run well, run smoothly, run securely. But we don't run the DNS. Nobody runs the DNS, because the DNS is itself a distributed network of tens of thousands or millions and millions of different elements, right? We do define policy in which we implement for top-level domains to determine how they're published and if they're published, because that's part of our role. But we don't control the DNS in any way more meaningfully than that. And as I noted, we don't control the root server system. We're going to talk about this in our presentation, but the root server system is 13 root server labels operated by 12 root server operators, one of which operates 2. ICANN is simply one of those 12 operators. We control our root server, and ICANN as an organization provides a facility for everyone to coordinate, but we don't run all the root servers. Okay, we have a question.
Yep, I'm just unmuting. Okay. Could you also unmute yourself, because I think you're still on mute. Dennis. I have unmuted you, but you are still on mute.
I'm sorry. I accidentally pushed the button. Sorry for that.
Yes, what's your question? Ahead. Oh, okay. Accidentally pressed.
No question. Okay, sorry.
All right. Continuing on the thing of what ICANN doesn't do is we can't remove domain names. If there's a website out there, www.example.net, and it's got content that's illegal in your country, or you find it to be immoral or objectionable or dangerous, you cannot come to ICANN and say, hey, you need to remove this domain name. Your law enforcement cannot come to ICANN and say you need to remove this domain name, because we can't. We have no facility to do so. We have no power to do so. Domain names can only be deregistered, removed by the TLD registry they live in. If it's a .net, then you have to go to the folks who run .net, VeriSign, and talk to them. ICANN doesn't control the second-level domains that exist inside a top-level domain, okay? And similarly, we can't block a domain name. For the same reasons that you might want to remove it, you might want to block. Blocking happens at the service provider level, okay? It happens at the network level for the network that you're on or the network you're running. It doesn't happen at ICANN. We're not going to block any domain names for anybody because we can't, and we're not allowed to. So let's talk about the things we can do, and let's talk about them in detail, which, in a way, I hope you'll find interesting. And the first is to coordinate the allocation and assignment of names in the DNS root zone. So this is probably ICANN's most well-known function. In the beginnings of the internet, beginnings of the DNS, we started with 7 top-level domains: com, net, org, which was supposed to be for non-for-profits, edu for educational institutions, .gov, which is the United States government, because the United States funded the creation of the internet, .mil, which is the United States military, and a very special and important infrastructure TLD, which is used today called .arpa. This is used for technical facilities like reverse DNS. We had a couple of rounds of new top-level domains, generic top-level domains, that we added on the internet, starting with around 2000, where we added 7 more, in 2003, where we added 6 more, and then the big round in 2012, 10 years ago now, we added somewhere around 1,200 new top-level domains to the root zone. And there'll be future rounds coming up in future years. And this all happens at ICANN. This is all within ICANN's remit. But there's more than just generic top-level domains. There's also, of course, country code top-level domains, which are super important. Country code top-level domains happen through different policy. Essentially, that ICANN follows what the United Nations does and what ISO standards get created that determines what is and what is not a country. So sometimes new countries get created. The two newest countries are East Timor and South Sudan. And so each one of those got a ccTLD assigned, which we delegated in the root. Sometimes new countries get created, but don't enjoy full global recognition yet. The United Nations has not formally recognized Kosovo as a new sovereign country. It's mostly recognized. And so the United Nations Security Council issued a directive to assign, for ICANN to assign a temporary country code top-level domain to Kosovo, which we've done, .xk. And as soon as the United Nations formally recognizes Kosovo as a sovereign nation, we'll assign the permanent ccTLD for Kosovo. Country codes, or TLDs in general, also get deregistered, right? Generic top-level domains can fail or they go unused and they don't need to be registered anymore. For some of the generic TLDs, there's a lot of things involved with corporations. And when there's merger and acquisition activity, sometimes that can make existing GTLDs redundant, so they get deregistered. And in the geopolitical landscape, sometimes countries don't longer exist for a variety of reasons. And when that happens, the ccTLDs themselves get removed to keep up with current events. So as names leave or enter the root zone, or when a TLD has to update some of its fundamental DNS data, like what are the name servers that are authoritative, for example, for the TLD, we have to update the root. And what that means is updating the root zone file. This is literally the zone file for the root zone. It's a single file. It's thousands of lines long, defining all of the TLDs and all of the authoritative name servers associated with it, plus all the associated DNSSEC data, right? This is what we do at ICANN. We are responsible for the editorial function of the root zone file. So we go through, I'll show you the editorial process on the next page, but once we've completed it, we then have to, the root zone file has to be generated and signed and published for the world to see. So here's a simplified version of what that looks like, okay? Let's say you are a TLD manager for .foo, and you need to change your name servers that are authoritative for your TLD. So you submit that change to ICANN via the IANA function, and we do a lot of things to verify that it's really you. We don't just accept changes either automatically or not automatically. We have to verify them. We have to validate them. We're going to do some out-of-band processes to make sure this really is you and this really is what you want to do. And we're going to validate that any change you make doesn't break anything. So we do a lot of careful review of the change. But once we've accepted it, we update our version of the root zone database. And then we notify the root zone maintainer, which today is a company called VeriSign. VeriSign has a contract with ICANN to maintain the root zone. And so what they do is they take the update out of our database and they do their own magic to it, to do their own validation and verification. And then they generate a new and updated root zone file. Once they've done that, they sign it. And once it's signed, they then send it into the distribution mechanisms. There's, a hidden master that distributes it to all of the different root servers and all the different instances of root zone servers, right? So when changes happen in the root zone, this is how it really happens. As we talked about, the root zone file is DNSSEC signed. And because the root zone file is DNSSEC signed, that actually makes ICANN and the IANA the DNSSEC trust anchor. So that's a really important thing. The root zone has to be properly signed and those signatures have to properly be managed, because all of the DNSSEC signing algorithms, the chain of trust, they all rely on the trust anchor being itself trustworthy, right? So IANA actually has full-time staff to manage the signing keys and to perform key signing ceremonies because we have to update the keys every 3 months or so to stay with best common practices. So we have about 4 key signing ceremonies each year, which happen at different key management facilities. These are data centers. And I want to show you these because it's actually kind of interesting. Up in the top right is a picture. It's a picture of some safes, some big, huge steel safes. Inside these safes are the key cards that have the encrypted keys that, when you put them all together, allow you to sign DNSSEC keys. These safes are really expensive and hopefully really secure. They're inside, you can see it, they're in the bottom right. They're inside a locked cage. They're inside that black cage. That black cage is locked, and it has all sorts of verification mechanisms for how you get in. That black cage is inside a locked room. You see a room where the gentleman and the photographer are. That's actually a locked room inside a locked data center, which is itself guarded by men and women with really big guns. And I'm not kidding. I recently visited one of these key management facilities. It's in the middle of nowhere. You couldn't find it. It's not on a map unless you know the address. It's fenced, it's guarded, there are dogs, there are rifles, there's all sorts of scary things. You have to get through a lot of security to get anywhere near these safes, which you have to get in to get anywhere near these keys. And the keys themselves are broken up into many different constituent pieces, and the secret parts of the keys are held by individual humans all around the world. All of which is to say, ICANN does a lot to try and keep the keys safe and secure. Final thing on DNSSEC and keys. The keys themselves, we actually want to re-sign them periodically. The key signing key that's used to sign all the other keys, we actually changed it for the first time in October of 2018. And that's something we're going to have to do again at some point. It's just something you want to do for cryptographic best practices, is change the key signing key periodically, every 5 or 10 years or something like that. And in addition to changing the key signature itself, we may want to change the algorithm we use to generate the key signature to make it more secure, to use a more secure, cryptographically more secure signing algorithm. What's interesting about this process at the root zone is no one had actually ever done this before. No one had ever actually rolled over the key signing key. And to date, no one's ever rolled over the signing algorithm at the root level. So these are processes we have to exercise. We have to learn from them. We have to figure out where there's potential brokenness and what happens if we do this. And by doing it, we learn the lesson so we can do it next time more safely. So that's part of what we do with ICANN with that really first mission we talked about. The next thing that we do is the development implementation of policies regarding second-level domain names, okay? I'm not going to read this whole slide, but I have emboldened this really first part because this is really, I think, the meat of it, which is how we deal with issues where we need coordinated resolution, where everyone needs to be on the same page in order for the DNS to work, in order for the DNS to be interoperable, secure, stable, and resilient. And it's from that example of this where so much of what ICANN's technical work falls. This is under an umbrella we call SSR, security, stability, and resilience. And it's doing our part to ensure that the DNS and the unique numbering system of the internet, IP addresses, autonomous system numbers, and the DNS work well and work securely for everyone on the internet. It involves essentially 3 things, because making policy about this requires data. So ICANN gets the data. We do it ourselves, or we contract it to people, pay experts to get the data, okay? The second part, which I'm not going to talk about, is about enforcement of policy, and that's a bunch of lawyers. I don't want to talk about lawyers today. Keeping everybody safe requires cooperation. So we'll talk just a little bit about that. So getting data. couple of good examples here of the way we collect and publish data to help people make informed policy decisions. We have this wonderful project called DAR. DAR is the Domain Abuse Activity Reporting Project. And what it does is it takes each individual TLD and it measures what abusive activities are happening via the names, the registered names in each of those TLDs. We get threat intelligence from intelligence companies around the world who we've contracted with to provide us feeds of threat intelligence data. And we're able to scour through that programmatically to find what's going on at the TLD, create some common measurements, and then we share those with the top-level domain operators, with the registry operators, so they can see what's going on objectively from our point of view, from a threat intelligence point of view. They can see what's going on, and they can choose to do things about it, right? So this is good data to help registry operators make decisions. Another cool project we did is called DNS Ticker, which doesn't really mean anything in English. Essentially what it is 2 years ago when the pandemic started with COVID and the coronavirus, we noticed a very big change, a very big new pattern of people registering coronavirus related names. And there was a belief that these names were going to be used for bad things. Phishing, spam, malware distribution, use humans' fear of the unknown against them to do bad things, right? So we created a platform where we're able to see all the new domain name registrations related to coronavirus terms, and then we track what they're doing. And where we see abusive activities, we then actually send a report to the TLD registry so that they know what's happening and they can make a decision based on their rules. Kindness. Kindness is a cool project that I'm working on. Kindness is a way where we're going to publish a basic set of best common practices that all DNS operators should adhere to as a very basic level of good practice and good security. Whether you're a cursive resolver operator, an authoritative resolver operator, a TLD operator, we are publishing a set of standards that are easy for you to comply with, but that are important for you to comply with. And when you do these, when you implement these, you are practicing kindness to the rest of the world by being sure that your platform is not being used for bad activities. Finally, the last thing I wanted to highlight today is something called the Name Collision Analysis Project, NCAP. It turns out that when you publish new top-level domains in the root zone, it's really important to ensure that they don't collide with existing names that are used elsewhere. And the best example of this was back in 2002, people wanted to register the top-level domains .home and .corp. If those sound familiar to you, you might be familiar with Microsoft Windows. And especially back in 2002, Microsoft Windows was the dominant operating system in this world. Microsoft Windows had for long time, years and years and years, used home and corp as labels in how they do Windows networking. And if we had registered .home and .corp as new top-level domains, there would have been name collisions all throughout the internet, which would have caused problems for everybody. So we didn't register .home and .corp, and we're not going to anytime soon because there are too many collisions. And so this project measures things like that and helps us predict if we register a new string as a top-level domain, what will the impact be in terms of collisions with other strings. But it's not just ICANN policy. It's not just top-level domains in the DNS that require really good data. Because more and more here in 2022 and in future years, it's government and regional governmental bodies that are creating specific legislative regulations that impact internet infrastructure. Let's talk about the EU. The EU has a current regulation they're trying to update, NIS2. And in NIS2, there was some draft text that would regulate, the EU would specifically regulate root servers in the European Union. This turns out to not be a good thing. It's a good idea. I can understand why the EU would want to regulate root servers. Root servers are really important, and we need to make sure that they're secure and they're operating well. Well, guess what? Root servers have been secure and operating well for 38 years. And ICANN was able to collect data and make a good argument to the regulators that here's why, if you want to accomplish your goal, you don't want to regulate root servers. Here's what you want to participate in. Here's what you want to understand. But the root servers regulate themselves really, really well. Okay. That was an argument we made, and that was an argument that was accepted. Okay. E-privacy regulation was a regulation from 2018 that accidentally made transit illegal. As when you go from your computer or your device to any site in the world, you go through many intermediary ISPs. And this regulation actually made that transit unlawful unless you gave your explicit consent to all those individual service providers on an individual basis. And that, of course, doesn't work. There's no way to do so, and there's no way that's workable for every datagram that you send across the internet. We're currently working on a thing called IDIS 2.0. This has to do with verifying identity in the EU, but they have an article in there, Article 45, which kind of breaks the web PKI system, which is how we exchange SSL certificates for TLS sessions. So we're working with many parties now to form what we hope is a more sensible and a more workable regulation that conforms with the idea of IDIS. Okay, so that's a lot of what we do at ICANN to help keep the internet running well and interoperable. Doing this, of course, requires cooperation of a lot of different people, a lot of different organizations. Some of that cooperation happens here at ICANN. We have some committees at ICANN that interested parties can participate in. The Security and Stability Advisory Committee, the Public Safety Working Group, the Domain Name Security Facilitation Initiative. You know, they have these big long names with these inscrutable acronyms, but that's okay. They're doing really good work to help promote the security, stability, interoperability, and resilience of the internet. Outside of ICANN, of course, there are lots of other organizations, like standards development organizations, ETSI in Europe, the IETF, W3C, ICANN stakeholders, ICANN organization. We work with them on common things that affect the things that are in ICANN's remit. Network operators, you know, network operators run the internet for real, right? So we work all the time with network operators, whether it's the regional NOGs, the big ones like RIPE and Apricot and NANOG. We participate all the time at national NOGs, FNOG and DKNOG. I had the pleasure recently of participating in last winter's DKNOG in Germany. And we work individually with network operators one-on-one on certain initiatives to make everything better. We work with security-focused organizations, CERTs, CERTs, incident response teams, an umbrella organization of these called FIRST, MOG, things like that. And ICANN does work cooperatively with global law enforcement. We meet regularly with Interpol and Europol and FBI and law enforcement organizations, big and small, all across the world, to help them understand how the internet works, to bridge and to liaise between them as law enforcement and the individual registries and registrars and network operators and what have you. So let's talk about the root name server system. This was the root name server system a week and a half ago on 2/22/22 at 7:43 UTC. Sorry, at 1943 UTC. There were 1,518 instances of root servers all across the world. And if you go to the website, root-servers.org, you can play with this map. You can zoom in all the way to any locale. You can go zoom into your home, and you can see all the individual root servers that are near you. It not only shows you that the root server is near you, it shows you its IP address, what its label is, who operates it, what city it's in. It's kind of a cool website. This came about naturally. The DNS protocol, as we talked about, was defined in 1983, and we set up the first root server in California in 1984. We started to scale this thing out so we could distribute more than one root name server and put them in geographically good places. And by 1997, we reached 13 root servers, okay? There are 13 root servers, and using Anycast, we are able to have many, many instances of these root servers. But there are 13 labels, A through M, and that's because that fills up those labels fill up the 512 bytes that are available in a 576 byte packet for each datagram that we send, okay? There are 12 root server operators. VeriSign, which is listed here first for A root, also operates J root. There are 13 root server operators. NetNod in Sweden is in Europe. RIPE NCC, which is in Amsterdam, runs K root. Icann'S itself, we run L root. But even though most of these are United States companies, they have many, many instances inside of Europe. There's like 300 or so instances in continental Europe from many of these. The University of Maryland, I think they have the largest number of root servers in Europe. And that's a university actually close to me here in the Washington, DC area. What's interesting about this, though, is we have 13 root name servers and 12 root server operators. And this history from 1983 to 1997, it actually evolved without any type of formal governance. It was just a bunch of DNS geeks, really. It was people who ran DNS and name servers who got together mostly on mailing lists and at in-person conferences like the IETF to say, you know, this is probably how it ought to work, so let's try it. And over time, a natural leader emerged. He's the gentleman pictured on the left with the big beard. That's John Postel. And John Postel really became the coordinator of the root server system and what root labels were assigned to whom, okay? And after he assigned the 13th root server to the WIDE project in Japan, he did so in 1996, and it turned on in 1997. But after he made that assignment, he actually died. It's 2022. That is, by my math, 26 years later, right? Did I get that right? 26 years later, we've had no process and no system to replace or add or remove any root server operators. There's nothing anybody agrees on, and there's no formal governance structure. It's kind of interesting if you think about that for something so incredibly important and fundamental as the root server system, right? How do we not have this governed formally with written down rules that we can all see that everybody's following? And if we need to, we can add or remove or replace root server operators. Well, despite the absence of a governance structure, it has worked. It has worked really, really well. We can say with confidence, the root server system has existed for 38 years without any downtime, at all. The system's always been up. We have two groups that do some coordination. Here at Icann'S, we have the Root Server System Advisory Committee, the RSSAC. And this is where the root server operators voluntarily agree to meet and to discuss things. They also have their own system called RootOps. RootOps meeting happen typically in coordination with IETF meetings. And nobody may attend RootOps except for the root server operators. And it's where they talk about some of the more technical things about operating a root server. RootOps isn't governance, it's just technical coordination. And it's a closed group that has informal meetings, okay? Closed and informal do not meet any definition of governance that we recognize. RSAC is a little bit closer to the idea of governance. It's organized underneath the bylaws of a formal governance organization, that's Icann'S. It does advise the community and the Icann'S board on matters relating to the root server system, but it's only governance body to the extent that the root server operators agree both to participate in RSAC and in Icann'S processes and abide by any decisions that RSAC makes. Because just like we talked about networks, your network, your rule, nothing can force a root server operator to abide by any decision or to do anything. They do so voluntarily. That probably needs to change. It probably needs to change because we just need to make this, we need to make a stronger governance model to protect the root server system in the future and to make sure that the root server system works well as things change. 38 years is a very long time for organizations to be doing something. And by the way, nobody pays them to do anything. It's expensive to run a lot of root server instances over Anycast. Who pays for it? Well, the individual organizations are paying for it. And who can say that tomorrow that an organization is willing to continue paying for it or can afford to continue paying for it? So we're working on a replacement system. We're working through the Icann'S system, the RSAC, this committee. We're working through the policy development process at Icann'S to come up with a new model for a formal governance structure of the root server system that allows us to monitor performance, to measure performance, to come up with baseline norms for performance, to talk about some of the financial considerations, and ultimately to give us guidance on how we add, replace, and remove root servers. We're working on that today. We're working through a governance working group that's working on all of these details. And eventually we hope to come to an agreement and implement a new system. Importantly, Icann'S doesn't run or control these governance activities. We simply provide the forum where the RSAC can convene. Some of the Icann'S staff participate in some of these discussions, but we only do so as technical experts, not in any authoritative capacity. The root server operators, they're the ones who collectively run root ops, and they are the primary participants in RSAC and this governance working group. We're at our final section, which is both the 4 and 5 combined. Very important thing we do in Icann'S is we give out IP addresses. There's a single pool of IPv4 addresses. There's a single pool of IPv6 addresses from 0 to the final number in the system, right? 255.255.255.255 and everything in between for IPv4. And what we do is based on IETF RFCs, we separate the pool into various buckets, and then we hand out those buckets to the constituent players. And the vast majority of the IP addresses go to, for the world to use, are distributed to the regional internet registries. ARIN in North America, LACNIC in Central and South America, AFRINIC in Africa, the RIPE NCC in Europe and parts of Western and in the Middle East, really, and APNIC, Middle and East Asia and all of Oceania, okay? And it's those regional internet registries that distribute the IP addresses further to internet service providers, to universities, to companies, to organizations that justify large blocks of IP addresses. And it's those ISPs or those universities which then give out the individual IP addresses to homes and businesses around the world. So it's a fairly distributed model. It's a hierarchical model, excuse me, for how we manage a finite resources, the IP addresses in both IPv4 and IPv6. And at the top of the hierarchy is Icann'S and this thing we call the IANA that performs the administrative function in order for this to happen. It's not just IP addresses though. It's also autonomous system numbers. AS numbers are just as important as IP addresses because it's AS numbers that define for BGP where the IP addresses are found, which routing domain, which network are these IP addresses found in. There are 4.2 billion AS numbers from AS0 to AS 4.29 billion. And one of the ways you can think about AS numbers, it's a way to identify what network you visit. If you go in your web browser to www.google.com, well, you're going to a set of IP addresses, but where the web servers are, where the actual content is, are actually part of AS 15169. That's the unique AS number, the globally unique AS number that's been assigned to the routing domain where the Google web servers are. Icann'S has its own web servers, and that's part of AS 40528. And these AS numbers, they're used in the routing process. They're used in BGP in order to send data where they need to go. Just like IP addresses, it's a finite resource, and everyone has to be globally unique. So we manage the pool from 0 to 4.29 billion, and then we separate it into buckets, and we give it to the RIRs, who give it to the individual ISPs and networks. Reverse DNS. When you think of DNS, you think of the common question, what is the IP address of this site, right? And you get back an A record or a quad A record. It gives you the IP address so your application knows where to go fetch some data. It turns out you can actually ask the reverse question. Well, I have a host name, I have an IP address. What is the host name behind that? This is useful primarily for two things. It's useful in email. When you have mail.icann.org and you assign it to 192.0.10.7, it's really useful for security purposes and anti-spam purposes that when a connection is made to your mail server by mail.icann.org, that you take the IP address that it actually connects on, because you know what its IP address is, and you say, hey, is this really mail.icann.org, or is someone spoofing the host name? And it's through the reverse DNS that you can get the PTR record that verifies, yeah, that this IP address is actually assigned to mail.icann.org. So there's less likelihood that there's spam coming through. It's also really useful for network troubleshooting. If you've ever done a ping or a trace route to a machine and you see all the different hops along the way, if there are reverse DNS records, it can display the host name. This is super useful for network engineers who need to troubleshoot problems in the network. Reverse DNS happens, it's administered it's part of DNS, so it's administered hierarchically, and the top level domains, it's in .arpa, and the SLDs for these are inatter.arpa and IP6.arpa. It's how the resolution works. It's how we build reverse DNS trees. Inatter.arpa and IP6.arpa administratively are run by ICANN. And then individual zones for IPv4 and IPv6 are then delegated to the RIRs, who then delegate more specific zones to the registrants of the network IP addresses. Final slide. One of the interesting things we do with this are also the time zone database. I'm in the Eastern United States time zone. I think many of you are in Central European time zone. Whatever time zone you're in has a name and it has an offset. Well, this has to be stored somewhere, the offset. It's stored at ICANN. We have the database, the protocol parameter registry, made by political bodies that set the time zone boundaries and the UTC offsets and deal with this daylight savings rules. Because computers have to be able to fetch those in order to build their own sense of time. So if you're familiar with this, you know that it's TZ or zone info that you do at a command line. And when you issue those commands, you're going and retrieving data at ICANN. I believe that's my last slide. So I hope this was interesting. These are some of the technical things that ICANN does that are part of our mission. And of course, some of the things we don't do. Thank you.
Thank you, David. I haven't seen any questions so far. I would just like to ask the audience if there are any questions for you. I can't see any. I can ask you one. Maybe someone will come up with more questions. I'd like to ask you, because you've done this several times, what would you say is the biggest misunderstanding about ICANN's technical mission that you're facing?
The biggest technical mission is they think we have the authority to remove domain names, remove top-level domains, to change objectionable content, to deal with spammers. When things happen on the internet that people don't like, they turn to law enforcement, they turn to their regulator, or they turn directly to us. And then the regulator or the law enforcement also turns to us and they say, hey, ICANN, there's something bad happening on the internet. You need to fix it because that's your job. But it's not our job. We only operate under the policies that our community creates. It's a very limited remit, as we've described today. And that's really the biggest understanding. I mean, I made a joke, but I really wasn't joking. My mother thinks I work at ICANN, so I control the internet, and that's what she tells her friends. And it's funny because it's my mom and a technical misunderstanding, but it's a really common thing, and it's not true.
Thank you, David. Again, last call is, are there any questions for David?
If not, I put my email address in the presentation. I'm david.huberman@icann.org. I'm also on LinkedIn. You're always welcome to connect with me or ask questions. Anytime you have technical questions about ICANN, we're happy to help.
Exactly. You're also very welcome. Oh, we have a question, I think. No, just thank you. Very useful. Well, that's nice. What I wanted to say is that your presentation will be uploaded on the page where you registered. The recording of this meeting will also be there. And there's also, you can find my email address there if you have any questions, and then I can direct you to David. And also there's information on how you can subscribe to an email list that we have for the region. It's for Central Europe and the Baltic region, because this is where we publish information about these kind of webinars. And I can already tell you that the next webinar will take place on the 21st of April, where David, I think you again will give just a half an hour short talk about the a short overview about the root server history. So I've seen this talk before. I can really encourage everyone to join, because it's I think it's very interesting and useful, and it's just half an hour. So please please join us in April. And with that, thank you all for joining. Let's hope for better times. Let me see if we have another question. No, there was no other question. Okay, well, thank you so much, and I hope to see you next month. Thank you. Bye-bye.